Hello there. So let's do a quick tutorial on calculating sounding tables values using basic interpolation. So today I'll be taking some values pre-written from the sounding table. I will share that much later. So I will just draw my interpolation table. If you're a mathematics student, you'll be familiar with this. So my circle, please. You'll be familiar with this circle. Yeah, don't mind my drawing. Yeah. Okay, that's it. So that's our interpolation table. So basically interpolation is it's a kind of technique we use to find an unknown figure when we have other figure, at least two other figure. For example, this case is a value of a sounding from a sounding table. We have the volumes of two figure, yeah, value. I'll be using centimeter today because the sounding table is in centimeter. So I have my first figure as 18 cm. So I'll put down my first figure. That's 18 cm. Yeah, we have 18 cm. 18 cm. Then the value as per the sounding table, there's for this tutorial there is already a sounding table for it, so I'll share that soon. So the sounding table value was 1.946, and that's it. Then we had another value that's 20 cm, and the value for the 20 cm was 2.051. So in interpolation, we call this the upper value and the lower value. That's how I call it. That's how I understand it. When I'm teaching, I like using basic terms to explain it. So in the sounding table, we have 18 centimeter giving us 1.946 volume. We have 20 centimeter, that's 20 centimeter, I mean the length of your sounding tip. 20 centimeter of your sounding tip giving us 2.051. That's liquid in the tank. So as a layman, it's more like the the 18 centimeter stands for the value of your sounding tip. Then the 1.46 meter volume stands for the value, the content of your tank, be it liquid, fuel oil, let's say fuel oil or fresh water, but that's the content of your tank. It's more like equating the length of the sounding pipe to what's in the tank. So normally there is already pre-calculations from stability calculation, loading calculations that will derive this 1.46 and 2.051 value already. So this is something that has already been pre-calculated when the vessel was built. So that's why we need a sounding table, because you will definitely need this guide. So when the reason for this interpolation is because when we now go to measure, to do sounding, and we find out that we have a value that is not in the sounding table, how do we get to know this value? Most sounding tables, as per tank capacity and tank sizes and tank design, some sounding tables are intervals of 2, sometimes sounding tables are intervals of 5, sometimes sounding tables are even intervals of 1, depending on the size of the tank. So we don't have long books, because by the time we want to accommodate all the decimal value, we find that we will be having a bibliography, walking around with a bibliography on board. So this particular sounding table that I'm using as reference has a difference of 2. From my value, you see 18, 20, the next one will be 22, 24. So let's assume during my sounding, I had a value of 10.5 in cm. Let's just say I have a value of 10.5. So what will this be? The sounding, the value of the liquid in the tank, X. We don't know it. So for us to do, that's where basic interpolation comes into play. So we do basic maths. The principle is I call this the upper value, I call this the lower value, and this is the unknown value. Yes, the unknown value. So we start with the either ways can work. Either you use the formula is the lower value minus the upper value divided by the lower value minus the unknown equals to the same thing you did here is here. You know that principle in mathematics that say what you do to the right hand side, you do to the left hand side. So just follow that principle. Or you can also say the lower value minus the upper value and the upper value minus the lower value. It will still give you the same answer. But for the purpose of this tutorial, I will use one of them. But I really seriously advise that you try the other way around and see what you can get. I will write the two formula out now. So let's proceed. So I'll be using meanwhile, let's get this clear. This is the upper value, UV. This is the unknown. This is the lower value. So let's do a key so we don't get confused. Key. For my key, UV means upper value. Mind you, I'm still reiterating, I'm calling it upper value because when I'm solving mathematics or anything physics, I like using values. I like using terms that I understand. Yeah. Another book can tell you upper limit, but for the purpose of me understanding, this is me sharing my own tips on how I go about it. So anywhere you see UNKN, that's the unknown. Then this LV is the lower value. Yeah, that's it. Lower value. Don't mind my handwriting. So that's the lower value. So let's start. So I said the first formula is the lower value minus the upper value divided by the lower value minus the unknown. So this formula, you now use it for whatever I do to the left hand side, you do to the right hand side. Or you can do the lower value minus the upper value divided by the upper value minus the unknown. Whichever way you want to go about it, it will still give you the same answer. So I will use the first formula for this calculation. Then you can try the second formula and tell me if you had the same result. But I bet you, and I'm very sure you have the same result if you did it properly. So for my left hand side, from the way I'm sitting and writing, my left hand side is the 18 centimeters. So from my left hand side, my lower value will be 20 minus my upper value 18 divided by my lower value will be 20 minus my upper value will be 10.5. Whatever I'm doing to the left hand side, I do to the right hand side based on the principle of equation. So equals to upper value 20 cm, my right hand side will be carrying 2.051 minus 18 cm, my right hand side will be carrying 1.946 divided by lower value, that's 20 cm, it will be carrying 2.051 minus the unknown for my 10.5 is x. We like using x. Yeah, mathematics, we always find our x's. So let's do basic mathematics. Let's do it as simple terms as possible. 20 minus 18, we have 2. 20 minus 10.5, we have 9.5. 20.051 minus 1.946 will give us 0.105. Then this is a complex figure rather, so we can't simplify that yet. We use the principle of cross multiplication. So 9.5 times 0.105. Normally I'm supposed to just do it multiply, but for the purpose of this teaching, we will write everything down. 2 into the bracket of 2, 1 minus x. So what is the value of 9.5 times 0.15? That will give us 0.9975 equals to 2 multiplied by the first figure. That's 2 multiplied by 2.051 will give us 4.102 minus 2 times x will give us 2x. Basic principle of mathematics: minus 2x equals to 0.9975 minus 4.102. We have minus 2x equals to, this is basically like secondary school math. But let's just do everything together. So this will give us minus 3.1045 is this. So we have x equals to 3.1045 divided by 2. So x will be equals to 3.1045 minus 1 divided by 2. 3.1045 divided by 2 gives us 1.55225. So x approximately will be 1.55. So basically, for sounding tables, most of them are always approximated to three figure. So please, if your sounding table is approximated to three places, so you have to approximate it. 2 is not up to 5, so we can't make it up to 3, so it becomes 1.552. So let's go back here. Our answer for x eventually will become 1.552. So when you dip your sounding tape to be 10.5 in length, you have an equivalent of 1.552 as your volume. So maybe I think you should try the second value and see in your spare time. Let's see how it goes. Or right until we can just do that. So let's just draw a quick line here. Let's draw a quick line here. Let's use the second one. We said lower value, that's 20 minus 18 divided by upper value, that's 18 minus the unknown 10.5. What you do to the left hand side, you do to the right hand side with the principle of equation. We now have 2.051 minus 1.946 divided by 18. That's 1.946 minus x. So you see we've changed it to the second formula. Let's see if it will give us the same answer. So this is the same thing. We have 2, but this time around 18 minus 10.5 will give us 7.5. So this will be equals to the same thing, 0.105. This will be 1.94, waiting to be simplified. You cross multiply, we will have 7.5 times 0.105 equals to 2 into the bracket of 1.946 minus x. So what is 7.5 times 0.105? Then we have 0.7875 equals to 2 multiplied by 1.946 will give us 3.892 minus 2x. We're always finding our x's. Same thing we will have minus 2x equals to 0.7875 minus 3.892. So we have minus 2x equals to this will be minus 0.7875 minus 3.892. That will give us minus 3.1045. So this cancel this, x will be equals to 3.1045 divided by 2. So x will now be equals to 1.55225, the just exact value, approximately into 3 decimal places, because my sounding table had 3 decimal places. We will now have 1.552. You will notice I didn't use a unit for the volume because I can't really remember the units on the sounding table, but I think it should be in meters. So that is it about today's class. So I'll just make a quick scan through this. So just recall, if you're having issues with your sounding table, like finding values for your sounding table, this is a very good This will be a very good guide and tutor for you to know how to calculate values from your sounding tip and equate it to the volume you have on your tank. So I hope you enjoyed today's lesson. Yeah, actually, this was from a colleague. Yeah, this was actually from a colleague. So I thought about it. Why not? If not, if I share this knowledge for everyone and everyone gets to know. Meanwhile, please, for knowledge sake, I am reiterating the upper value, lower value on my unknown, that is X. That's my own way of knowing my values. So you can decide to call your own anyway and find your way. There are other ways of finding values in your sounding table, but this is the interpolation method. And I actually prefer this one because it's straightforward, easy to do, and it's one of the simplest and oldest kind of mathematics. Do have a beautiful day. Bye.